Good afternoon, guys. My name is Ricardo Ardila for the third time, and along with my partners, Avi Sharir and Villatoro, we're here to talk about our project, which is on multi-purpose serial arm. If you guys remember from our previous presentations, we had this idea of having designing a path tracing SCARA that would get the path from an LCD screen, right? But we had a couple problems with it because of the three main reasons. LCD connection, it wasn't viable because on robotic projects, the type of LCD that you could attach is just like an 8-bit LCD like the one they had on the Woos project. Obviously, you're not going to get a path from it, obviously. Then prismatic joints. On any typical SCARA, you got to have a prismatic joint, and we're not very, let's say we haven't had much experience on it. We just do regular joints. And the third reason why we decided to leave this idea behind is because of something that Adrian told us about the sending commands to the servos. And the thing is that when you have a path that is given to you from a mouse, obviously the commands that you're going to send to your servo are going to have to be variables. And with the type of microcontrollers that we have, the commands that you send have to be predefined. So that was the three main reasons why we had to scrape that off. And we thought that we might come up with a multi-purpose serial arm. Go to the next one. So our new objective right now is to design something that specializes in pick-and-place tasks. And if you think about it, this is something that you could apply at an industrial level way more than just drawing paths, which is good, but this is something that has a lot more applications. I'm going to pass it into Avi, who's going to tell us about the parts we use, how we assemble them.
Basically, we have the bottom of it, we have it going on the turntable. This one's going to give our radial motion. We also have the arms going to go so that way we can lift the arm up and to allow for the elbow and an additional servo to close the grip. Kind of looks like a weird person if you look at it the wrong way, but yeah. We tried several different configurations. This one for the bottom was one of the first ones we had. Obviously, you can see that we drilled a couple holes in it because we tried to do it with two servos, but apparently we weren't able to get the exact same feed from both servos at the same time. So we had to go back to the original idea. One problem we noticed definitely was that since we're no longer traveling with just a horizontal motion, since we're also traveling vertical and we have to deal with gravity, we're wasting our batteries a lot faster, so servos might not be as compliant as we'd like. I'll leave it to Oscar so he can talk about the programming.
Okay, on the programming, we use the visual sequence control. And this is a software that it allows you to program the road in an easy way. We use this software because it lets you program 32 servos at the same time. And you don't need codes to control the robot arm, and it's easy. And it's compatible with the BS2. You know, the one that we use. The software looks like this. We did learn how to use the software because it looks easy in this way, but it's complicated. This software allows you to put a maximum and minimum to each servo, and it allows you to make different degrees for it, different speed for it, and it makes the work easy for you. And for presentation purposes, we thought that it was easier to present it like this. Also, this arm is also capable to use a basic stamp. So you can program it with either this software or basic stamp, both ways.
Something I would like to point out about the interface of the visual sequencer is that it avoids you of actually go ahead and write a code. How do I explain that? You have these little boxes which allow you to create sequences. So you could actually, like these boxes, each one represent one of the servos. This is the servo right on the bottom of the platform. This is the one that acts as a shoulder, then the elbow, and then the claw. So what do you do with that? You just move this, slide it, and it actually turns it. So it's way much better than going for a 4 next loop and sending commands and having to control that. Not only that, but when you achieve a position that you're going to find important, you just save it and it creates a sequence and it just follows it. So that's basically what we're doing. We're just going to the positions we wanted to achieve, saving them, and then run it without the need of a code. If we will have to do this again, this is some of the improvements that we can make to it. There was an idea that we found at the beginning and we couldn't develop it. As Oscar said this is compatible with BS2. And one of the commands that the BS2 has is that you could, it has an integrated chip so you can connect a PlayStation controller. So that will be, like, it would be amazing to actually control the robot with a PlayStation 2, but we couldn't, our skills in programming were not as advanced to actually go ahead and do that. Another thing that we would improve to a robot if we would have to do it again is to get a platform that is wider at the bottom, so to avoid a little bending, because that's an issue. On the demonstration, you're going to see that we have to hold it, because otherwise it's going to twist a lot. We would use more powerful servos at the shoulder, actually, to find a way to assemble them without it actually breaking or drying the battery, and add ridge rotation to make it more complete. And this is a couple videos of some of the tests that we were doing. This is actually Dan's idea. So the function of this robot right here is to... Is it going to play?
I don't think so. Doesn't play.
Do you have it on the...
Oh, I don't have it on the USB. Doesn't let us play.
Okay, let's do something. Go get it on your flash drive and we'll go with this presentation.
Okay.
In the meantime, you go get it. Okay, we'll show you those videos later. Those are simple applications in grabbing a can and putting it in another place, and then the other one just gets one of these brackets and puts it in another place. This one that we're going to do here, hopefully it'll work. It's actually more complicated. What we're going to do is we're going to place two batteries on different positions on this box. The robot's going to grab one,